2 through 20.
It will get better. All right, Aubrey, this is section 1-3. We are on page 23. Here's the homework assignment. If you guys want to write this down, go for it. This is homework for 1-3. This is going to be probably a better section than the last section, although everybody said it was easy, like the last section was easy. This is going to be even better, I feel. Okay? We're going to do a little bit of algebra today, but not hard algebra at all, okay? All right, here we go. This is line segments. Oh, line segments. Okay. All right, so lines from yesterday, lines went on forever and ever in both directions, right? But line segments have a starting point, have an ending point, which means they have a specific length, right? Okay, so here's something that we know about line segments. This is a really crazy concept called the betweenness of points. Are you ready for this?
No.
This is a key concept right here, okay? I'm going to draw you a picture over here in the corner. Let's say A is here and B is here and C is in the middle but not necessarily in the middle, right? It's in between them but not necessarily in the middle, right? Here is what the betweenness of points says. Whatever this length is from A to C, if I add it to whatever this length is from C to B, that will give me the length of the whole thing.
Oh my gosh.
Whoa. So if this is 2 and this is 5, the whole thing is 7. Now what happens if they tell you that that is 7 and that is 2 and we don't know what this is?
Is that literally the first
Can you subtract? That is literally the first problem. So over here, example 1. They are giving us
I will still need a calculator.
XY is 13 or is 11.3, YZ is 3.8. They are saying what is the measure of XZ, which is the whole thing, right? How do I do that? Try to add this in your head if you can. Try to exercise your brain. It is 15.1 what?
Centimeters.
Centimeters. Beautiful. That is way too easy. Like, give us a ton of them, right?
Yeah.
Woo. It's centimeters. It's centimeters. Okay? That is example 1. We love it. Okay. Next page, go to example 2. This gets a little bit harder in the fact that they have fractions going on, okay? And here we have the whole length is 13 and 3/4. One of the smaller lengths is 6 and 5/8, and we are in fact finding QR, the missing length, which is what I don't know. Okay, so I am going to subtract 13 and 3/4 minus 6 and 5/8. All right, don't get a calculator out. Don't get a calculator out. Okay, we know from Algebra 2 and probably like 4th grade math that we cannot subtract those if they have a different denominator. So I'm going to change this guy, and this is going to be 6/8. Okay, so here I can just subtract. What's 13 minus 6? 7. What's 6/8 minus 5/8? There you go, and that is in feet. Okay, that was subtraction rather than adding. Good? Are you writing this down? Okay, you should. That was example 2. Can I move on? Okay, now it gets a little bit harder. A little bit harder because we have to do some algebra. They want us to find the value of x. Okay, real quick. Everybody look at where the question is being asked. Find the value of x and BC. So how many answers are you going to have? 2. And if you just solve for x, you get it half wrong. Okay, you have to go back and reread the question because a lot of times in geometry, they will have you plug it back in, all right, and find the actual value. So 2 answers here. Solve for x, but we're not done with there. Okay, so looking at this diagram, AB is just this unit long, and that is x, right? Okay, we don't know what x is, but we know that that's how far AB is. BC is 2x plus 3, and then the whole thing is 4x minus 12. How do I do this? Okay, the small piece plus the other small piece makes the big piece, right? Okay, so this is how we're going to set it up. One of the small pieces was called x. Another small piece was called 2x plus 3. And the whole piece is called 4x minus 12, and then we solve for x, okay? Am I going too fast? That piece plus that piece makes the whole piece. Are you writing this down? Okay, now hold on just a second. Here's my equal sign. We're going to have to do some algebra. This is taking us back a little ways. How many terms are on this side?
3.
Can you combine any? What? X and 2x makes how much?
3x.
3x plus 3 equals. How many terms are on this side? 2. Can you combine any? 4x minus 12. Okay? Now, let's deal with the x first. Are you going to move the 3x over or the 4x over? Minus 3x minus 3x. What's 4x minus 3x? 3 equals x minus 12. Then let's add the 12 over. If you do that in the same step, good for you. You sure can. X equals 15. Are we done?
No.
BC.
Plug it back in.
We're done with the X part.
X is 15, so x equals 15. They want BC. BC was the 2x plus 3. So 2x plus 3 and 33. Do you see what we just did? I went through that kind of fast. Okay? BC is 2x plus 3, so I put 15 in here. 2 times 15 is 30, plus 3, 33. Got it?
Yep.
Was that too fast? That's okay. That was example 3. And look how long they made it. That's so silly. Why did they make it so long? I have no idea. Okay. All right, example 4. I like this example. Yeah, let's do this one. Okay, example 4. Use between us points. Daryl is visiting the Space Needle in Seattle. Do you guys know what the Space Needle is? It's like a little, I don't know, do they have a picture of it? Right here, this guy. It looks like a UFO standing on top of like a little support or whatever in Seattle, Washington. Okay. He knows that the total height of the Space Needle, so now we're doing a line segment that's going up and down. It's just a vertical line segment. The total height of the Space Needle is 605 feet. The distance from the ground to the observation deck, so the bottom of the UFO, ground to the observation deck is 10 feet more than 6 times the distance from the observation deck to the top. 10 feet more than 6 times the distance. 6x plus 10, that's 10 feet more. This is 10 feet more. Well, that means you're adding 10. Then 6 times. Okay, then what's this little segment right here? That's just x, right? Okay. All right, now how do I figure out what x is?
We did what we did last time.
Little piece plus the other piece equals big piece. So x plus, and if you want to add those together right away, that's totally fine. 605. Okay, on the left side, if I combine like terms, I've got 7x plus 10, yeah, equals 605. Now what?
Subtract your 10.
Subtract your 10. 7x equals 595.
Oh, just what?
Yeah? Is that 595? And divide by 7. X equals 85. Okay, now, that's in feet, by the way. Okay, we want to know, help Daryl find the distance from the ground to the observation deck. Is it 85 feet? No, ground to observation deck is this guy. So I'm going to plug the 85 in here.
520.
6 times 85 plus 10.
520.
520. Or we could have taken 605 minus 85, and that would be the remaining, right? Whichever. Okay, you boys, do you need separated?
No.
Okay. Show me that you don't. 520 feet, that is the answer to example 4. Good? All right, perfect. Okay, next. They're talking about line segment congruence. Okay, real quick. What does it mean to be congruent? Same. When we start to get into geometric figures, they are the same shape and the same size. When we're dealing with line segments, really, line segments don't have a shape, so we're dealing with really just the same size or the same length of line segments, okay? Now, are you all listening? This is the notation that they will use to show you that they're the same. These two things are the same, and I know because these little tick marks, we call them tick marks, okay? Tick marks mean those things are exactly the same length, okay? So if one's 1.7, the other one's 1.7. Now, the notation that they will use, quit. This segment is called AB, yeah? AB and CD, and then they use this symbol in the middle. This is the symbol for congruent. Okay? Everybody write this down. The congruent symbol, if you are drawing it, is an equal sign with a squiggle over top. I think it's called a tilde, maybe. Is it? Like in Spanish? Yeah. Okay, so it's an equal sign with a squiggle on the top, and that means congruent. That means the same length. Stop. Turn around. All right, let's go to example 5. Here we go. We are trying to solve for the value of x. I'm reading this question right here. Find the value of x if q is between blah, 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 all the things, right? Find the value of x. Now, let's say we don't have a picture, okay? Q is between P and R. P is here, R is here, Q is between them. Do I know that Q is exactly in the middle? Not yet, but then when they go down here and they say PQ and QR are the same, now I know that Q is exactly in the middle and this is the same length as that, all right? Okay, so going over here, I know that this length is the same as this one, but I don't know the overall length, right? Doesn't it have to be like that one plus this one is the full thing? What? No, I don't want to put them together. Set them equal to each other. I know that they're equal. The tick marks say so, right? So 6x plus 20, I know has to be equal to this thing, right? Okay, and then we just solve for x. So, what are we going to do first? Distribute the 2 through, okay? 6x plus 20 equals. Distribute the 2 through, and you get 2x plus 12. All right, now let's get the x's together. You want to subtract the 2 over or subtract the 6 over? Minus 2x minus 2x. Okay. 6x minus 2x is 4x plus 20 equals 12. Subtract 20, subtract 20. 4x equals negative 8. And dividing by 4 is... What the heck? How can x be negative 2 when we're talking about distance?
It's backwards.
X is the variable. X isn't the length of each one, right? So x could be negative just as long as when I sub it back in, it's going to be positive for the distance. Make sense? Okay? Now, am I done? X is negative 2?
Nope.
Find the value of x. If blah, 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 blah. Do we have to sub back in and find anything else?
Nope.
This one, I just have to solve for x and that's all, right? Questions about that? Which question?
Same distance. Why do you have to use 2 different equations?
We done?
Because it's like a way of saying like different things. Okay, so for example, let's say we're talking about like money that's equivalent, right? This amount of money is the same as this amount of money. But let's say here I'm dealing in quarters and here I'm dealing in dimes, right? So I want to know how many quarters is the same as how many dimes or whatever, right? So it's just like representing it in a different way, but it's equal on both sides. Is that a stupid equation or a stupid way to say that? I don't know.
You can say
That's
US
just
dollars and euros.
what we do. I don't know. What?
You can say US dollars and euros.
Right. Conversions and stuff. Yep. Okay. All right, there you go. Use your time to work. Maybe really quick. Hold on. Maybe really quick, go to number 10 and I will help you. No. Let's go to number 16 really quick. Okay? Go to number 16 really quick. Everybody look at number 16 really quick. Everybody look at number 16 really quick. You can use your, you can draw over on this side if you want. Because you don't have to do any of the odds, yeah? Okay, so I'm going to do this over here. 16. I know you can't just do that, sorry. Okay, but you can use the space, okay? Now, it tells you up here, find the value of x, or excuse me, yz if y is between x and z. Okay, so x is here and z is here, and y is between them. Now, do I know that y is exactly in the middle? Then I'm not going to put him exactly in the middle unless I know that for a fact. I'm going to make it so it looks like y is to one side or the other. So I'm not led to believe that those are equal to each other, right? Okay, I'm doing that on purpose. So here on 16, it says xy is 11d. This length right here is 11d. Yz, this length right here is 9d minus 2. And the full thing is 5D plus 28. Okay, now how do I do this?
Subtract or move the 2 to make it through up top. and
Okay,
subtract
we're not, but just,
So do you
11D plus
11D.
minus 2 equals 5D minus 28.
Yep, equals 5D plus 28. Yep.
So do you have to draw?
Add the 2
I
over.
mean, not necessarily. I would draw the picture for one of them.
Equations.
What?
So they already write the equation down.
Right. I would draw the picture for like one of them.
So
So you know X, Y, and Z or wherever, but you only have to really draw it once, okay?
Subtract 5 over.
I'm going to do this.
Well,
I'm going to
add
go 20D, and I'm going to add the 2 over. I'm going to do a couple steps at a time. 5D plus 30, and subtract the 5D. 15D equals 30, and what's D equal to?
2.
2. Okay, D equals 2, and find the value of the variable. D equals 2, and we want to know what YZ is. YZ is this guy right here. So I'm going to plug 2 into there. 9 times 2 minus 2. 16. I'm going to say YZ equals 16.
if you just have to
Good.
find D, right?
No, you have to find YZ on each one of them. Each one of them. Find the value of the variable and YZ for every single one of them. You plug it back into the equation, kiddo. They give you what YZ is. They give you the equation for YZ on each one of them.
So where do you plug it in?
To YZ, you plug it in right here. D was 2. Right, child.
Oh, okay.
I asked first.
I just asked. You hear me?
I have been asking.
Can you both go and be
Yes.
good? Go. All right. Okay, I'm going to stop.